let a and b be integers and not both of them 0, then the greatest common divisor of a and b, and we denote it like this, so we sometimes say the GCD of a and b, it's going to be the largest integer d that divides a and divides b. So we're looking for the largest number that divides both a and b. So for example, the GCD, let's see, what is the GCD of 12 and 18, right? So we can look at the divisors of 12. So 12 is going to have the divisors 1, 2, 3, 4, 6, and 12. 18 is going to have the divisors 1, 2, 3, 6, 9, and 18. And we are interested in what is the largest one that they share. So of course, they both share 1, they both share 2, they both share 3, they both share 6, and that's it. So that means that the largest divisor that they both share is 6, and so 6 is the greatest common divisor of 12 and 18. And so GCD, let's say, of 35 and 49 will be 7. 7 is the largest number that divides both these numbers. And you can have something like GCD of 17 and 24 equal to 1, which means that apart from 1 that divides every number, no other number divides both 17 and 24. So when this happens, we say that they are coprime. So they're relatively prime. So here we say relatively prime. Also, sometimes we say that they are coprime. Okay. So of course, one could always list all the divisors of both the numbers, but this can be quite slow if the numbers are large, and this will be relevant for solving problems later on. And so we would like a better way of maybe finding this than actually having to list out all the divisors. And so a much better way is something called the Euclidean algorithm. And this is how you do it, but I think that the easiest way is just to show an example, but you can go and look at the slides to read the algorithm. So if we look at the example, let's say we want to compute the GCD of 252 and 198. So the way that it works is you first divide, so take the largest number and divide it by the smaller one. So 252, if you divide it by 198, it's going to be 198 times 1 plus 54, right? And let's write the step here on the left. So essentially here I'm saying divide 252 by 198. Then what you're going to do is the next step, you will divide the 198. So you're going to divide this number over here by the remainder that you found, the 54. So divide 198 by the remainder 54. Okay, so if we do that, then 198 is going to be equal to 54 times 3 plus 36. Now we do the same thing. We're going to divide this remainder here by 36. So now you divide 54 by the remainder 36. And so if you do that, you will get 54 is equal to 36 times 1 plus 18. And now again, you divide the 36 by the remainder 18. And when you do that, you will get 36 equal to 18 times 2 plus 0. And this is where you stop. When you get a remainder of 0, this is where you stop. And your GCD will just be this number over here, this 18. So it's going to be the previous remainder that you found, right? Before if you look at the sequence of remainders, this is the remainder that came before the 0, right? So then GCD of 252 and 198 is equal to 18. And so this is much quicker. Doing these divisions is much quicker than actually having to list out all the factors in one, all the factors in the other, and trying to find the largest one. And so just to recap, so how does it work? Start with the larger number, divided by the smaller number, and you're going to have this equation here with the remainder. Now take this number and divide it by this number and write it out in this equation here. You'll have a remainder also. Now take this number and divide it by this number here, and you'll have this equation and you'll have a remainder. Then take this number divided by this number, you'll have here, when the remainder is 0, the previous remainder is your GCD.